Welcome again to the Byte Attic. This time, another American computer in this episode, an Atari 800 XL. I think it is the best sold Atari 8-bit computer back from the early 80s. Atari, this brand, is a big thing for me from my child self. When I was a kid, the name and the logo Atari were very evocative, evoked a lot of respect and wonder. Anyway, I don't know the condition of this computer. I actually didn't turn it on yet. But of course, I'm not using the original power supply. I will be using just a normal USB charger. It's just that on this side, there is a plug that conforms to the DIN standard of the Atari power jack. Other than that, this is just a normal, I think this is a 2 ampere, maybe 2.5 ampere, 5 volts USB charger. You need at least 1.5 ampere because I think this machine consumes 1.5 ampere. So if you go for 2, you are safe. This computer has 2 video connectors. One is for S-video, requires a special cable. I made one, it's quite short, that's why you that's why the thing is a little bit in a funny position, because the cable is short to get to the TV. And the other one is the normal RF output. So I think my charger is on. Yes, it is. So let's turn it on. Let me put the TV. Oh yeah, it's already on S-video. On-off switch is here. Okay, let's go for it. Let's hope it works. Yeah, it works, but in black and white. What the hell? Let me try the RF interface. Well, as you can see, there is color in the RF output. The keyboard not working. It keeps pressing semicolon by itself. The image is horrible. So yeah, we have a few problems here. So I've checked online, and it seems, surprisingly enough, that in many of the Atari 800 XLs, probably some other 8-bit models of Atari as well, the supposed S-video output only contain brightness information. It's meant for monochrome monitors. They didn't wire the chroma signal to the jack. I'm sure the Atari produces a chroma signal. The Antic chip, which is the video display processor in the Atari line, produces luminance and chroma, luma and chroma. In other words, brightness and color information. So it is on the board somewhere. I would just have to find it and connect it to the DIN jack here for the monitor output, so we get color in S-video as well. It shouldn't be too complicated to do that. We've just done it for the VIC-20 in the previous episode. I think this one will be simpler. And the other thing we have to do is to sort out the keyboard. And some of the keys are not working, and it keeps detecting a key press on the semicolon here when I'm not pressing anything. So this is probably the keyboard membrane here that is busted. It's a common failure. I do have a replacement. So at least these 2 things we have to do, and then service the board. And I have a surprise. I'll tell you later what this is all about. For now, let's just open it up and have a look at the condition of what we find inside. Here we go. That's the keyboard membrane, which is probably at fault here. I have a little technique to open it up using my head as support. I just have to pull the ribbon cable from there. There you go. And there is a big RF shield here, which is totally unnecessary today. Back in the 80s, people would watch free-to-air television broadcast through the air that you would pick up through an antenna, and the circuitry here inside would generate radio frequency signals that could interfere with televisions. I remember my mother complaining to me every time I had some computers on. She couldn't watch television properly, couldn't watch the 8 o'clock news. And this was meant to reduce that interference. But today nobody watches free-to-air television. Here in the Netherlands, free-to-air television doesn't exist. It's not broadcast already for several years. So we don't need this RF shield in here. I will lose it unless I need it to assemble the machine. Otherwise, I will just lose it to allow the computer to breathe better, to ventilate better. You have to be really careful using a vacuum cleaner on a board, because the rushing airflow can produce electrostatic discharge. But in this case, I just could not vacuum clean this because it was really filthy. Let's try and remove the RF shield. And now the last remaining one is the one that turns but doesn't pop out. I'll press it from the other side while turning in the hope that it, yeah, now it came out. Okay. Yeah, this is to avoid shorting, because the shield is metallic, so if it touches these little terminals here, it could cause a short circuit. This is in pretty good condition. If I put the RF shield back, I will put this back as well. I will need to. Okay, so that's the other part of the RF shield. Pretty good nick as well, a little bit of oxidation, nothing too serious. I hope I don't need to put it back to improve ventilation. So this is the board, the glorious board. Clean it a little bit with some compressed air. This is ESD safe. That's the RF modulator. I also want to open it. It's a much better RF modulator than the one in the Sinclair line. Okay, so this is our board. Let's see if I can identify all the chips. There are 5 custom chips on this architecture. I believe this is the Pokey chip. Atari has these 5 customized chips on this board. I think this is the Pokey. It is a programmable sound generator, produces those very characteristic sound effects of the Atari computers and some video game consoles. It also performs some input-output interface functions. I think it scans the keyboard. This is the keyboard connector in here. So this chip is also responsible for scanning the keyboard. This, I believe, is the PIA. It's another custom, Atari custom I/O chip. PIA, I think, stands for Programmable Interface Adapter or something like this. It performs the rest of the general purpose input-output functions. This is an important one. This is the Sally chip, the Sally CPU. which is Atari's own custom version of the 6502 CPU that was used in a bunch of computers back in the 80s, including the VIC-20, where you saw me replace the 6502 with a modern equivalent by using a little board I made, an adapter board that allows the modern chip to interface with the old logic on this board. This adapter would not be sufficient to replace the SALI chip because there are extra changes. It's a custom version of the 6502, and Atari changed the pin of the read-write signal, if I remember correctly, and they added a signal, an input, a halt input, whose objective is to halt, to stop the CPU when the graphics chip or the programmable video processor, which is this one here, I believe, when this processor is trying to access memory, trying to get control of the data and address bus, it issues the halt signal, which then stops the 6502 on its tracks, so they don't compete for access to the bus. This chip, I think this is the so-called antique. I forgot what the acronym stands for, but this is the video display processor. It produces a digital video signal, which is then translated into an analog luminance and chroma signals by this chip here. And I believe this is called the GTIA chip. Yeah, it basically transforms the digital video information produced by the antique into chroma and luma, which then goes to the video generation circuitry in here. These are the memories. These are probably this is 74 logic, TTL logic. That's probably for some address decoding. This is some glue logic. These are the ROMs. I think this is the BIOS ROM, the basic input-output system. In Commodore lingo, this would be called the kernel, which has the operations the computer executes upon starting up. And this is the basic ROM, which contains the instructions for interpreting the basic language used in this computer. And that's obviously a cartridge slot in here. I want to remove this piece of plastic to be able to clean it properly. And this is the RF modulator, which I think is not working very well. When we tested it, the image was horrible, but I'm not going to use it anyway. I am going to use the video port in here, which is S-video, but I will try to perform a modification so we get color on S-video as well, not only monochrome information. Beyond that, if you look at this board, it's typical Atari. It's a very nicely laid out board. You can see the bus in here going to the expansion slot. It is very clean. Atari went further than other companies like Sinclair and Commodore in consolidating logic into customized chips. In the Sinclair line, you have the ULAs, the uncommitted logic arrays that consolidate a lot of 74 type logic. Some of the chips you still see in here. In the Commodore, you have the VIC, the VIC-2, the SID for sound generation. But in the Atari line, 5 custom chips. Well, the CPU is not very custom, but it is officially custom. So they consolidated a lot, which makes the computer less, how to say, reverse engineerable by just looking at it. I'm not fond of it. The reason I like old computers is that by looking at the board, you know what's going on, you know what is doing what. And in modern computers, if you would open the PCB of a modern computer, you would find 2, maybe 3 large chips that integrate all the logic, so it's all invisible inside the epoxy package of the chips. You don't know what's going on. I like when you look at the board and you see what's going on. And Atari took quite a step into consolidation, towards consolidation, and therefore hiding things a little bit. So you have things like a sound generation chip, which also scans the keyboard, and you would think, why to combine, I/O logic with sound generation? Well, because some of the logic blocks perhaps are common, or because it's easier to lay out. There are reasons for doing that, but it becomes less obvious what the computer is doing, where and why. I will try to do something to make this computer a little more, quote, visible in a different way to try to compensate for this. It's a surprise you see later on. So what I'm going to do now remove this, clean the board a little bit better, and maybe recap, because I see, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 perhaps, 11, 12. Yeah, there are quite a few electrolytic capacitors, and obviously I'm going to change them. These capacitors were soldered on a very large ground plane that was sucking up all the heat from the soldering iron. So it was quite a challenge to remove them and remove the excess solder, and then soldering a new one back in the same place. It was quite a struggle. Yeah, all those little capacitors on the top left corner of the board, if you are looking at it head on, had this problem of being soldered onto large ground planes, making it difficult to replace them. I always inspect the result of doing a new solder joint, and sometimes I even check continuity with the multimeter to make sure. Now I'm removing 3 capacitors at the same time. You see me removing them there. They all have the same value, that's why I'm doing them at the same time. And they are bipolar capacitors, so if you do this, make sure to pay attention to those 3. You have to replace them with also bipolar capacitors. Now that's the first axial capacitor, not the first and the fourth. The 3 ones on the upper left corner were also axial. So this board has a mixture of radial and axial electrolytic capacitors. Another little radial one. And then a final inspection for good measure. The board is neatly recapped. These are the casualties. Oops. But these were already bipolar, so you have to replace them with equally bipolar capacitors. They were these 3 here. I replaced them with a higher rated capacitor with capacitors that are nonetheless smaller than the originals. So this goes to the trash bin. And what I want to do now is to clean the board very well. There is a reason for that, which I will review later. For now, just come along with me. I'm going to clean these connectors first because they make a mess around, and then I'll clean the board around the components. That's the plan. So we start with the contacts. You know what's coming. My two-step contact cleaner. So this is the cartridge port and the keyboard port. So that was step one. A little bit here on this port as well. And the power jack. Okay, that was step one. Now, step two.
These foam pads I'm using, they are very handy. Normally they are used in the maintenance of pinball machines or arcades. They are very convenient for you to wash a board very thoroughly with IPA, reaching every little nook and cranny without having to actually put the board in a washing machine, which is not something I would recommend because of the salts in water and all that. Even little details like that ugly tape that Atari has placed under a number of resistors and along the edge connector and a couple of other components, I don't like the way they look. So I'm removing them all and making sure that the board is absolutely clean and looking very nice.
Okay, the board is now recapped and clean. Well, clean enough. I'm paying more attention to aesthetics than I normally do. The tape that was here was a little bit aesthetically disturbing to me, so I removed it. You will know soon why I am so more careful now about the aesthetics of the board. I don't know whether you can see it, but I've noticed that there is oxidation on the legs of most of the chips. This is the Sally CPU, there is some oxidation there. I think this is the interface controller, there is oxidation there. So I decided that I will reseat them all. I will remove them all from their sockets, clean their pins properly by using a little fiber pen and applying some contact cleaner, and then I'll put them back. let's do a quick test just to make sure I didn't screw up anything when recapping. I'll do it with let me try the S video, although it has only one color. I mean, it has no color actually, but it's enough to test. So let's see if it's still working. I have to turn on this thing. There's the TV. Let's flip it on and hope that nothing got worse. A black and white image would do. Yeah, it didn't get worse, so we are good to continue.
Join me in part 2, when we will be carrying out some modifications to the Atari's video circuitry. Well, rather a fix than a modification, because Atari just screwed up big time. They didn't just forget to wire chroma to the monitor port, they actually wired composite video into a S-video jack. So we will fix that up and continue the restoration.